G'day there. You're watching the Aussie BIM Guru, and well, tonight, it's night time here, I'm going to cover a tutorial where we look at creating cropped floor plans for selected rooms in a model. This can be a really common task when you're doing things like plans for apartments, where you may need to do marketing plans, and we usually really crop down these plans to the extent of the room only. I'll be using a combination of Dynamo, Revit API, and Python today. So we'll follow a few steps. First of all, we're going to get these selected rooms. So not just any rooms, not just using selected elements in Dynamo, we're actually going to use the rooms physically selected in Revit by the user when they run the script. I find this can be a really good input when creating tools that need to respond to a specific thing that can be quite hard to select. Rooms in this case in Dynamo are quite difficult to select because you have to make sure you get their crosshair and that you don't pick up other objects. As well as this, we're going to check, do these rooms have a view created for them yet? We're going to use the views naming system that we're going to create ourselves to detect if there already are views that we cannot create an extra copy of, because of course we'll get a warning in Revit if we have two views with the same name. It just doesn't work. From there, we're going to use Dynamo instead to get the outline curves of the room and then offset them a little bit. And finally, we're going to create the cropped plans for each room using the Revit API and Python. So today I'll be using Revit 2024 and also the built-in Dynamo build at the time of this particular video. And you can use this in pretty much any other Revit or Dynamo build. It's a pretty versatile workflow, but in this case I'll also be using the DS Python 2.7 package in order to support Python in this particular build of Dynamo to the engine that I use, which is Python. So it's assumed you'll have some fundamental knowledge in Revit, bit of Revit API knowledge hopefully, as well as some Python basics, but I will try to explain everything as I go in this tutorial. So without further ado, let's just jump straight into the workflow. So I'm going to be using a sample model from Autodesk in 2024. This, I think it's a Snowden Towers model. Now this model is, in this case, in imperial units, so I will at one point be using a measurement that will be provided in, I believe, feet. So if you are watching in metric, don't necessarily use the same numbers as me because they might be in millimeters, they might be a lot smaller. But I'm just going to start by jumping over to Dynamo. So in this case, I'm just going to boot up Dynamo from the Manage tab. And to begin with, we're going to focus on using Python and the Revit API in order to get the selected rooms in the model in our selection. So I'm going to start a new script. Now the first thing I need to actually do is get a Python node. Now I'm going to be using my boilerplate, which is a custom template that I use in Python. Now it obviously has a lot of things you won't have by default. I'm just going to zoom in a little bit. But what you can do is just jump over to my GitHub, Aussie BIM Guru, and if you go to repositories and you go to miscellaneous, you should find a file called pythontemplate.py, and you can use this contents in order to begin your Python nodes. You can also put this Python template in your app data folder for Dynamo for Revit, which will enable your Python nodes to kick off using this template. So if I just jump to a folder and I go to my app data folder, and I go to Dynamo, and then I go to Dynamo Revit, into my build, you'll notice I've put this python template.py here, and this means that every Python node I open will begin using the full template, which is just really useful versus having to remember all of the contents of a typical boilerplate when you're developing. So I highly recommend doing that as well if you're not already using one. Okay, so to begin with, we're going to be using a few things in this boilerplate. We are going to be getting rid of a majority of the header all the way down to the document manager. I'm not going to need to use transactions to begin with. And as well as this, we are going to have Revit API, but we're not going to have API UI. We're also, in this case, we're going to need everything except for the app. Now we're going to need the UI app and the UI doc in order to call on the selection class, which we'll have a look at shortly in the Revit API. I don't need any of these starter functions either. I'm just beginning with a pretty raw set of elements. So the first thing I'm going to do is get all the view plans in the model. So views which happen to be plans actually fall under a class called a view plan. So I can actually go and grab all the plans in the model very quickly using this class and a filtered element collector. So I have used filtered element collectors on some previous videos. I do recommend watching them if you're not overly familiar with them, but we're going to use filtered element collectors by class in order to get all the plans in our model and check their names just to make sure that of the rooms we do select, their name isn't already being used in another view in the model. As well as this, we are going to be looking at the rooms in our selection. So I'm just going to jump over to the room class. And we're going to, in this case, also be using their category property and the name of that category, which should be rooms, in order to check that the things we have selected are rooms and filter everything out that isn't actually rooms. I'm also going to be grabbing the selection class, which belongs to the UI selection namespace, sorry. And from the UI.selection namespace, we're going to be getting the selected elements as well. So under methods, we should have an option to get the element IDs from our selection. So this is all the things we're going to be using from the Revit API to kick this off. So to begin with, I'm actually going to get a prefix as well from the user, because we need to put a prefix on our view once we create it. So I'm going to say view prefix, and let's just say the prefix is room plan space dash space. This will have the room number appended on the end, and that's how we create and check for names of views created per plan. So I'm just going to get all the view plans in the model, and I'm also just going to collect the prefix, which in this case will be prefix equals in 0. We're just taking the first input into the node, which is room plan space dash space. To get all the view plans in the model, we are just going to just call this variable view plans all, and I'm just going to begin by creating a filtered element collector, targeting the current document, which we've stored already up in this line using my boilerplate. We're going to use the of class method, and in this case we'll be targeting view plan, and we'll use the toElements method. Now we could also apply the where element is not element type method if we do want to exclude view templates as well, because I think they do fall under the view plan class. Plan-based templates also belong there. So if I run this at this point, now I do have an error. We don't want that transaction manager here, and I'm also just temporarily going to send out these view plans as the out variable. But we can see now I've collected all the view plans in the model. Now I'm also just going to do names underscore all is equal to. Now I'm going to use a shorthand here. I'm going to use list comprehension to do a shorthand for statement. So I'm going to say v.name for v in view plans all. And what this will return is the names of all the objects in view plans all. And we now have the names of all the plans in the Revit model, which we can now cross-check when we're finding the rooms in our selection that we want to pass forward. And if they do already exist by name, we're going to not send them out to the final output of this node. So for the next step, I'm going to get all selected rooms that do not have a view. So to begin with, we need to get our selection. In this case, I'm just going to call this selected is equal to, and we're using UI.selection, that namespace we looked at before. And we're going to use that get element IDs method. And this should return all element IDs we have selected. So what I'm going to do is just go into Revit and just select just a set of rooms to run this. And now we can see we have the element IDs that are currently in the active selection in Revit. So when you teach someone to run this tool, you would tell them, first of all, select the rooms you want, then hit play in Dynamo Player, and it will use those rooms in the actual run of the script. It's very intuitive. We're also going to create two empty lists. We're firstly going to get the rooms that we send out and the names that we send out as two empty lists that we're going to build. So I'm now going to iterate across this list of IDs. I'm going to say for I in selected. And at the moment, we might have things that aren't actually rooms in here. So I'm going to try to get their category and the name of that category. So I'm going to say try, just in case it doesn't have a valid category. I'm going to say that in this case, cat is equal to I.category and then .name of the category. So we're chaining properties together to get the name of the category of the object. Now there's a problem, there's actually a mistake I've made here. I actually need to turn this into an element. This is currently an ID. So I'm going to go and call that E, and instead I'm going to say that E is equal to doc.getElement I. I might just call this ID, just so it's easier to understand. And this will firstly turn the ID into an element, and then we can ask that element, what is your category and what is your name? Now we're doing this all in a try except statement. So in this case, it is, if it does fail, we are going to have to declare our except branch as well. So I'm just going to say except, and in this case, we'll say cat is equal to just double apostrophes. It's not a category in this case. Now we could also say cat is equal to none. That's another option, but for now I'll just say double apostrophes. So I might just comment this, try to check category. Now that we have this category, or we have a failed category, so double apostrophes, we can now actually check if room is relevant. So we're going to do two things at this point. The first thing we need to do is check if the category name is rooms. So I'm going to say if cat is equal to, so double equals, rooms. Now that's the first thing we need to satisfy. Then we'll go to the next level. And now we also need to check if room has no view. So now we have all the views of the plans in the model. So logically, if in this case, this room already has a view, its name should already be in our list of names, names all. So I can say, in this case, maybe I'll just say this is room name is equal to E dot name. At this point, this element should be a view. And I'm going to do number. Sorry, at this point, this element should be a room. So we know the number property should be safe to check at this point because it always has a number. So we've got the room, and then we're going to say if room. Actually, sorry. We'll call this view name. This is the view the view name we're going to look for because we're also going to send this forward in the output of this node. So I'm firstly going to take the prefix and add it to the room number. So in this case, for example, if the room is 20, we should get room plan space dash space 20. And we can then check, is it actually in all the names in the model? So I'll say if view name is in names all. But in this case, we actually want to say if it's not in names all, then in this case, we're going to append this to rooms out, and then we're going to append the name to names out as well. So in this case, which is the view name that we're going to pass forward. So rooms out, we will append the element, which is still E from earlier, and then we're going to take names out and append, in this case, view name. So the final thing we want to do now is take these two variables, in this case, names out and also rooms out. And we can see now we're passing forward both the 4 rooms because they currently have no views created, as well as this, we're also passing out the 4 names of the rooms as well, which we can use further on in our script. Now I'm going to switch back to Dynamo because we're doing a few things with geometry now, which are much easier to do in Dynamo, totally possible in the Revit API, but it will become a very complex, very in-depth tutorial if I were to do this whole next section purely using Revit API. So for now, I'm just going to save my script, and I'll just call this room plans by selection. So we're now going to switch into assessing geometry of elements instead. So I'm just quickly going to get my reference just to make sure that I don't make a mistake as I go. I do this quite a lot with my videos. It definitely helps. So we now have 2 things. We firstly need to split these up into 2 variables. I like to use a code block. So I'm going to say that in this case, names is equal to out 0 and rooms is equal to out 1. So we're indexing our output, so we can see that index 0 is our names, index 1 is our rooms. And this will let us split these 2 out into elements because we can only currently send one thing out of a Python node. So this is the workaround to split our data. I'm now really just looking at the rooms to begin with, and I am going to be using the finish boundary node to get the finish boundaries of these particular rooms. And I can now see that I've got these rooms. Now the problem with the finish boundaries is sometimes they have holes in them. There's always going to be an outer boundary in a room that's going to have the largest area of any of them, and then there's going to be smaller ones sometimes contained within. So we're going to process these. So to begin with, I'm going to use the polycurve by joined curves node, just to join these together. And as I go, I'm just going to turn off my previews. We can now see we have one polycurve for one room, and then we have 2 polycurves for the other ones. Now what we need to do with these is actually patch these into surfaces so we can check the area that these polycurves take up. So we now have surfaces instead, and from these we can check their area. using surface area. And we will always know that the largest possible surface in area will be the biggest one that we want to offset, because it has to be the outermost surface to be the largest one. So at this point we have these surfaces, which I can go back actually and just turn back on. We have these areas, so with them we're going to use the list sort by key node to sort each sublist of surfaces, some which just have one, by their areas, and then we know that we'll have them in the order of their areas, and then we can take the last item or the largest item in area. So I'm going to feed in lists and keys. Now I will get an error saying that the list and keys will not be supported because we have different input types. To fix this, I need to go to use levels, and I'm going to switch to level 2 and level 2 to tell this node to work across each sublist and each sublist of keys. This will sort each list by the keys in individual sublists. And I can see the largest item in area is going to be the last item. So what I can do now is use the last item node at level 2 to work across each sublist with longest lacing. And I should now have the largest possible surface from each set of surfaces that were generated from the outline curves of the joined polycurves of the rooms. So I can now proceed with these. So now I can go back and turn off some of these previews. And I should now just have one surface per room that we want to deal with. So now that I have this surface, I'm going to process it. So I'm just going to probably group these together. This is sort of a little function in itself. And I'll just say in this case, get outer curves as surface. Because with these surfaces, we're now going to get their curves. So we're going to use the perimeter curves node, in this case, to get the perimeter curves of each surface. I'm then going to join these back together. Now that seems a little bit inefficient. We have had to take these apart and put them back together again. But the reason I'm doing that is because I want to offset these. So I'm going to use the polycurve.offset many node, which will allow us to offset these polycurves by a set distance in assigned direction, so away or into the surface. I'm now going to get a number node. Now this is where there's some imperial units technically, so I'm just going to say for now 1 foot. And I'm also going to say false for extend circular. And I can see now that I've offset the outside of these surface curves so that we can use these as a slightly offset crop boundary around the rooms themselves. So at this point, I can just turn off some previews. Again, we've got probably a little bit more than we need to see. I might just do that for now because that sort of helps understand the surface and then the offset outcome as well. So this should return a polycurve, which is going to be a perfect input for us to use some Python to crop these views that we can create from the rooms to create our room plans. So again, I'm just going to block these together as a function and just say create offset curves. Now all of that is technically possible using the Revit API, but it's very complicated. It would be a very long tutorial, probably not very good for YouTube viewing, but if you do want to explore it in the Revit API, it's definitely possible. Don't forget the Dynamo forums are a great resource if you're ever exploring more difficult areas that you might not be familiar with, but for YouTube it's probably not a really interesting topic, it would be too complicated. So next I'm going to create a Python script. And we're going to do 3 inputs. We're going to take those names that we created before, the rooms they belong to, and also these polycurves, which still all line up to the room itself. So I'm just going to go back and collect the names, the rooms, and the polycurves. Again, I'm using my boilerplate, so you'll want to do that as well. Now we only need certain parts of the boilerplate. Again, we don't need the whole thing. In this case, for now, I am going to need proto geometry because I am going to be converting some Dynamo geometry into Revit geometry. I'm also just going to keep the geometry conversion. I believe that we may not need proto geometry. I think we just need geometry conversion. I'm going to keep the document manager and the transaction manager, but again, we don't need the UI. We just need the Revit DB. This time we only need the document. We don't need the document manager. And I'm also going to keep, in this case, these 2 methods, or sorry, functions. The first one will make sure that an object provided to the input is in the form of a list, and if it's not, it will make it a list. Likewise, the other one will do the same, but it will also unwrap the elements or the lists to make sure that these elements are workable in the Revit API. These are fairly fundamental techniques, so if you're not familiar with them, I do recommend going and looking back at some of my Python fundamental series where I talk about some of these concepts. Anyway, we're now going to define some inputs to go into our node. So I'm going to say that names is equal to toList, and we're going to pass this over our first input, so our list of names. Now, if we only had one name that came out of this, this will ensure that this is turned into a list of names with one object. And this means we can iterate over this object as a list safely. I'm also going to say rooms is equal to, now I'm going to use the UW or unwrap list function from above, and this will also not only force this into a list if it's not, but it will also unwrap the outcome as well. And finally, I'm going to make polycurves equal to toList in 2, because we're not going to pass this through the Revit API directly. So these are our 3 inputs. Now I'm also going to be collecting the active view and the active view's view type ID, because we will need this in order to create some floor plans of the same type of view as our active view, which should hopefully be a floor plan. But this would also mean that you could run this in an RCP format and create an RCP as well by getting its view type, which is an RCP. So just to explain what we'll be doing with that, I'm going to be getting the active view, which is a property of the document that we're in, the active view property, and that will return a view, which we can then apply the get type ID method to, inherited from the element class. So the first step, we're just going to get the active view type ID. So first of all, we're going to get the active view. I'll call that view underscore active is equal to doc, so the current document, dot active view. I'm then going to say the view type ID is equal to, and then we're going to take the active view and we're going to use that get type ID method. I think that's ID, uppercase, lowercase, yep. And this is a method, so it also needs to provide the brackets, even though there are no arguments to provide to it. Let's just double check this has worked. We should see an ID, and there it is. That's the ID of the view type we're using in this particular floor plan that we're looking at. So now that we have that, the next step is we are going to be working within a transaction. So I'm going to say in this case, create and crop plan views per room. And we're just going to do everything in the next step within the body of a transaction. And I'm also going to be creating views and appending them to views out, which will finally declare at the end of our Python node as the final output. And this will just be a list of the views that we create in our scripts. So what we need to do first is we are going to be working across our variables, but we need to create a function in order to create and also to crop our plan views. So I'm going to create 2 functions. The first one will be called create plan. Now let's think about the inputs we're going to have available for this step. So we're going to hopefully have a room, which isn't really relevant. We're going to have a name for the view, which is relevant. And we're also going to need, in this case, to get a level. So what is the level going to be? Well, it's going to be the level of the room itself. So we do actually need the room in this case. So I'm going to take in, firstly, a room. I also need a name. And I also need type ID. And so what's the first step? Well, the first step is we have to create a plan. So we're going to go back to the Revit API and just check out the view plan class, which has pretty much everything we need here. So we're going to firstly get the view plan creation method. So in view plan on the methods, we can see we've got a creation method, and this will take a document, a view family type ID, and a level ID. Now it doesn't actually take a name, so we will need to set the name of the view after it's created as well. So in this case, I'm going to firstly create the view. So I'll just say create view. So again, we're gonna store this to a variable called view. I'm going to say view plan.create. Remember, the first argument is document. The next one is the type ID, And the final one is the level ID. Now we don't actually have the level ID yet. So in order to get the level ID, let's just have a look at the room class and see if we can get the ID of the level. So under room properties, it turns out level ID is actually a property of the room class, which is great. So in this case, the step we need before this is to get the level ID of the room. So in this case, I'll say level ID is equal to room.level ID. And now we do have everything we need to create a plan. What we need to do also is name the plan. So I'm going to say view.name is equal to name. And this will pass the name that we provide in the function through to the newly created view itself. And finally, we'll return the view. So we'll send the view out of this step. So I'll say return view. So let's take our function and put this into a loop. So we have three things we're going to work across in parallel. We have names, rooms, and polycurves. So in order to do this, we need to use a zip loop. So we're going to say for R and P as variables. In this case, these will be local to the loop. We're going to work across rooms, names, and polycurves. So we're going to say for this in, and we're going to use the zip keyword. And then if you've seen this loop before, basically we pass in the three sets of variables parallel to R, N, and P. And we can now work across these lists in parallel. Now in the loop, first of all, I'll create a plan. So I'm going to say view is equal to, so we're going to store the output of this function to a variable called view, which means we can continue forward with it. And in this case, I'm going to change room to R, N, or name to N, and the type ID is going to be this view type ID. So we can see I'm borrowing the R and the N as we work across rooms and names. The next step we need is to crop the view. Now this step's a little bit harder. We're going to be using a few things to do this. So I'm going to create, first of all, a function. That's the most important step. So I'm going to say def, and let's call this crop plan view. So in this case, we're going to take in two things. We're going to take in a view, and we're going to take in a polycurve. Whoops, spelling error, there we go. So we're firstly going to have to get what's called the crop manager from the view. And this is basically going to return an object which will allow us to later on set the crop to what's called a curve loop. A curve loop basically being similar to a polycurve, but just in a Revit API sense. So we'll very quickly just have a look at this. If I go to the view class, cool. Under methods, once it loads, we should find a get crop region manager, get crop region shape manager, which should return in this case the crop region shape manager. Come on. And that's a class in itself. There we go. And we can use this in order to set the crop shape and also to get the crop shape. We'll be setting the crop shape. So this will take a curve loop, which is going to be an object we create out of the polycurve that comes in from Dynamo itself. So the first thing we need to do is process the polycurve after we've actually got the crop region shape manager. So I'll just call this region manager is equal to view.get crop region shape manager with no arguments. We now need to we'll get the Revit curves from the polycurves. So to begin with, we're going to get the curves from Dynamo. And in order to do this, we're going to be using the polycurve.curves, which comes from Dynamo, not the Revit API, of our polycurve. And this will return each individual curve in that particular polycurve. We're now going to turn those Dynamo curves into Revit curves using, again, a comprehended statement. So I'm going to use the c.toRevit type, which will turn Dynamo curves into Revit curves. And I'm going to do that for c in curves _dyn. So in that case, we now should have curves that belong to the curve class in the Revit API that these Dynamo curves represented. So there's a little bit of back and forth that we're establishing here. Now the next thing is we're going to be creating a curve loop, which we know we need to use to set our crop boundary. So I'm firstly just going to create a new curve loop object using the curve loop creation method here. So that, I believe, should be listed under the curve loop class. So we can establish a new curve loop using this method, or this function, I should say. We can see the constructor is just simply curve loop bracket, close bracket. And to this curve loop, we're going to append all those Revit curves. So I'm now going to say, so for C in curves underscore RVT, so for each Revit curve, we're going to append C. Now, I could probably simplify this process a little bit if I use the for loop up here instead. So I could technically say for C in curves dyn, and I could say C underscore RVT is equal to C to Revit type, and then I could just append CRVT instead and take out this comprehensive statement. That's probably a little bit easier. It's a note here that I am using the capital A in append, because in this case there is a append method specific to curve loops, which adds the object into the curve loop object. It's a little bit different to using a typical list append, where that's lowercase a. So do make sure you get that one right. So we should now have a curve loop object that we can apply to the view. Now, if I go to the view class, I'm going to check a couple of things. So let's go back to the view class. I want to make sure, first of all, that the crop box is on and it's applied. So in this case, if I look at properties, I'll be able to find a couple under crop box, so we can see crop box active and crop box visible. We want to make sure we can both see the crop box and also that it is active. So we're going to make sure these properties are on. So I can just make sure crop is on. And I'm fairly sure we should just be able to set these both to true, even if they're already true. So in this case, I'll just say view.crop box active is equal to true, and view.cropbox visible is also equal to true. And this should just ensure that this newly created view is going to have a crop that's on and visible as well. Finally, we're going to set the crop shape using the curve loop. So I'm going to say that region the region manager, and we're going to apply the set crop shape method to this object, passing in our curve loop. And this function should now crop down the plan that we've just created to the extent of the polycurve. Now, I've probably made a typo in here somewhere, but we'll see how we go. So the step we want to do after we've created our view is crop it. So we don't need to store this to a variable. We're just going to pass the view out that we've created before as a variable. We are going to pass view into our function, and we're also going to, in this case, pass in polycurve, which is P. So finally, we'll append the view. So to views out, and notice I'm using lowercase a there, we're going to append view. Now, assuming I haven't made any typos here, this should hopefully just work. I think I'm still in automatic mode, so that might cause some challenges. We'll see if this actually stops spinning. Sometimes being in automatic mode isn't always the safest thing to do when you're writing scripts that create objects. Oh, there we go, automatic mode did finish. We can see what's happened is we've created 4 plans and we've got no errors, so I'm going to assume this actually worked. Let's just have a quick look at what's actually happened in Revit. So I can see I've got plan 401, and there we go. We can see it's cropped down to outside the room. Now, obviously, there's heaps of things turned on, like section markers and elevations. You might want to change the view template. You might want to change the view type, depending on what you use for apartment plans. You could always provide these as inputs to your script and use the Python script to set those properties as well. It's up to you. But we can see that this has successfully created cropped views for each of these particular rooms, which is great. So let's go back to level 4, and let's just try running this through Dynamo Player. So I'll just create a watch output, and we'll just say this is views created. Now we could also probably create another output back here just for the names of views as well. So let's go and boot up Dynamo Player, and we'll just make sure that the function we've included in here that should emit rooms that already have a view is actually going to function now that we have some views created. So I'm just going to make sure that I'm going to go to my desktop as a folder in Dynamo Player. Oh, there we go, it's already there. Great. We've got our graph here. And our only input is the prefix, but remember we do want to select, in this case, we're going to select a few rooms. Going to hit run, and we should hopefully see that some of these will not have a view created. We could also potentially create an output to show the user which ones already had views if we want to. That's also totally an option. But we can see it's only created what it had to, so it's only created 401, 403, just 403 and 405, because we already have 401, but we now also have 403 and also 405 because they have the matching name. Now, of course, if these names change, then the script won't detect them. So you will want to be fairly consistent with your system. So now if I go back to 405 and I run the script, it's probably going to create a 405 because technically the name we're looking for doesn't exist anymore. So you will just have to make sure that you do stick to a pretty consistent system, whatever one you want to use, but usually view name is the main way you can do that. So that's pretty much it. So hopefully that's been an interesting tutorial that's covered some extra things you can learn about the Revit API, but also shown how you can sort of mix the best parts of Dynamo with the Revit API and Python to create some fairly versatile and functional tools that can do some great things. Now, of course, you could build on top of this. There's lots of things you can do with this type of script. You can make it so that it creates views of a given type, or also if it has a view template applied that's more suitable to the view. There's lots of things you can do here. But I hope that was an interesting tutorial, however. So, as always, you can find this script and other tools over on my GitHub, which you can see here. And if you found this tutorial interesting, feel free to like, comment, share, subscribe, let people know about it. And you can also reach out to me at my email if you have any questions, or you can also comment down below. Also, if you have a video request, feel free to let me know. Whilst I can't guarantee I'll be able to do everything, I do try to take on the interesting requests that I think would be a valid topic for others. Otherwise, I might contact you via email and just help you one-on-one. Anyway, I hope you enjoyed this tutorial today, and I look forward to seeing you in future similar videos. Thanks. Take care. Bye.